Now we want to explore this idea of zeros. Zeros, again, love zeros. So what do zeros mean in terms of the polynomial function? Well, zeros are when our function is set equal to 0. And the x's that are produced are what we call the roots or solutions of the functions. Basically, where it touches or crosses the x-axis are the solutions of a particular function. So let's look at a function here. F of x equals x cubed plus 3x squared minus x minus 3. So based on this idea, we need to set this function equal to 0. So how do we solve that? Well, this is where a lot of our factoring experience is going to come into play. So let's factor this to see what its solutions of x are. Factoring this, I have 4 terms. I'm going to try to group them because grouping sometimes works with 4 terms. So it looks like I can group the first two. I'm going to have an x cubed plus a 3x squared. And then I'm going to factor out a negative 1 on this one. So I have a negative 1. And I have an x plus a 3 in there. On this first one, I'm going to factor out an x squared. Left with an x plus a 3 minus 1 times an x plus a 3. I can see grouping is working now because now I can factor out an x plus a 3. And I'm left with an x squared minus 1 equals 0. Now that it's in factored form, I know that either the first pair, x plus 3, has to equal 0, or x squared minus 2, or x squared minus 1 has to equal 0. That's true at x equals negative 3, and that's true at x equals plus or minus 1. All right, before I continue with this idea, I know many of you guys are thinking, wait a minute, what in the world just happened? And I don't blame you at all, because these steps right there might have been a little tricky for us if we're rusty with our factoring. And if that's the case, I really encourage us to practice our factoring and try to remember many of the factoring techniques that we've had. And the more practice that we have, the more that we're going to be able to factor some of these terms or some of these polynomials in ways that are useful. All right, if this was still a mystery to you, still a cloud, wipe it away for a second, and let's just continue on with the part I want to show you that's relative or relevant to this particular problem that's new. We have found our zeros. Negative 3 plus or minus 1 are our roots, are our solutions. And that's helpful because I know I have some graph. And so let's just start to generically build it. Tells me I have a crossing point at negative 3. Well, let's put all the points in here. Just some generic grid line. So trust me, that looks like a graph. What do we know? Well, we know a couple of things that we're learning here. First of all, we know that x is a solution, or x equals negative 3 is a solution. So whatever my graph looks like, it crosses right there. X equals plus 1 and minus 1. I know I have a graph that crosses there. Is there anything else you know about this graph? Oh yeah, the leading coefficient tells us in behavior. Oh, that's useful. So it's in behavior, it tells me it's odd, and my leading coefficient is positive. So it tells me I have a graph that begins in a decreasing fashion, and it ends in an increasing fashion. So the only way to create a graph that connects to these 3 points, but has in behavior like that, has to enter this first term from below. At some point in time, it's going to turn around, because it has to go back to that dot. And that graph's going to continue down, but at some point it's going to have to reverse and go back through the other solution. Something such like that. So based on just 2 types of ideas, in behavior and looking for its roots, we have a fairly good idea what this complicated polynomial function looks like. Isn't that cool?